In the article titled "Evidence that Bottlenose Dolphins Can Communicate with Vocal Signals to Solve a Cooperative Task", written by Stephanie King, Emily Guarino, Katie Donegan, Christina McMullen, and Kelly Yakala, the researchers examined the ability for bottlenose dolphins to communicate amongst each other to solve a singular task. Dolphins would communicate through whistling to each other. To test this, they used 4 dolphins, 2 males, Delta, 9 years old, and Reese, 7 years old, and 2 females, Aletta, 33 years old, and Calissa, 17 years old. The males and females were paired together to form dyads. In many cases, previous cooperative experiments have followed the rope pulling paradigm, where 2 or more animals would pull ropes connected to a reward that they could not reach individually. However, the researchers adapted the cooperative task where the dolphins were to swim across the lagoon and each press their own button simultaneously. This was connected to a computer and a speaker to give signals and collect data. The margin of error was 1 second for the dyads. If the dolphins are successful, it will play a success sound, and the dolphins are given a reward, a fish in social interaction. If the dolphins fail, the speaker will play a failure sound, and will receive no reward. As the graphic shows, there were 9 different phases that manipulated the release time and vision of the dolphins. For each phase, different goals were set to determine if the dyads succeeded in the task. However, for trials 6 through 8, only the male dyads participated, as they were much better in the initial trial phases. The experimenters examined whether the presence of whistles influenced outcomes, and if so, did the amount of whistles affect the outcome. They also measured the timing of whistles. In total, the female dyad performed 396 total trials, while the male dyad performed 505 total trials. The top graph shows the average time for the dolphins to press the button. Red represents success and blue represents failure. The line in the middle is the cutoff time. For both dyads, if the dolphins whistled during the task, it led to significant more trial success. This next graph compares whistles to time. The top graph shows when the whistles occurred, and the whistles tended to occur towards the end of the trial. On average, the male dolphins were more vocal, producing 2 whistles per trial, and the female dyad producing less than 1 whistle per trial. For both dyads, significantly more whistles were produced in successful trials versus failed trials. The bottom graph shows the relationship of timing of the last whistle and the first button pressed. We can determine that if the first button press occurred after the last whistle, the dyads were much more likely to succeed. Although the sample size is small, the results show that the bottlenose dolphins used in the study are capable of vocalization to execute coordinated and cooperative tasks. To conclude, at the very least, some bottlenose dolphins have the cognitive ability to use communication to actively coordinate behavior. This also provides new evidence that humans are not the only species to use vocal signals to communicate and cooperate with one another. Thank you all for listening to my presentation about dolphins.